Hi class, welcome to exercise 5H, solving quadratic equations by completing the square. In this lesson we have just one example, and that is example 19, solving quadratic equations by completing the square. And your pre-learning for this example are questions 1, 2, 3 and 4 in the new book, and questions 4, 5, 7 in the old book. Okay, we'll get straight into the introduction. If you hope to complete this lesson, then you must complete the first lesson on completing the square, as well as the first lesson on solving quadratics. So in that lesson, we already began to solve quadratics with grouping. And to solve ax squared plus bx plus c equals 0, with grouping, we rely upon factors of ac to sum to b. So this means that our quadratic must have integer solutions. And how often do you reckon that happens? Completing the square does not have these limitations. And because of this, it's a fact that some people automatically use this technique. And also, once again, it's worth noting that some quadratics have no solutions, some have one, and some have two. And this is a lesson where it becomes very clear which quadratic has which amount of solutions. Okay, I'm going to see you in the next section. There are many similarities between completing the square and grouping when solving a quadratic. The steps that you take when completing the square are: 1. Put all the terms on one side of the equation and 0 on the other side. And then the next step is completing the square. Then from there's actually two directions which we could follow. The first direction, which I'll call direction A, is 3A, factor with the difference of perfect squares. And then following that, you solve with the null factor law. And the second direction, which we'll call direction B, is 3B, rearrange the equation with the perfect square, i.e. x plus a all squared, on one side of the equation, and then put all the numbers on the other side of the equation. Then you just need to take the square root of both sides and solve for x. Okay, so I'm now going to show you both of these in example 19, where we will solve the following quadratics by first completing the square. Alright, in part A, we have x squared plus 4x plus 2 equals 0. So that means our b from ax squared plus bx plus c is equal to 4. So therefore b on 2 squared equals 4 on 2 squared, which is just 4. And if you remember the completing the square tricks, this means by adding and subtracting 4, we've just added 0, so we haven't changed anything. So we now have x plus 2 squared minus 2 equals 0, because this part here is x plus 2 squared. And of course, minus 4 plus 2 is minus 2. Alright, so we can now rewrite the 2 as the square root of 2 squared, and that becomes x plus 2 plus the square root of 2 multiplied by x plus 2 minus the square root of 2, just by using the difference of perfect squares. So therefore, by the null factor law, x plus 2 plus the square root of 2 equals 0, or x plus 2 minus the square root of 2 equals 0. So in other words, x is equal to minus 2 minus square root of 2, or minus 2 plus the square root of 2. Now if we go back up to the top here, the alternative method starts here. So instead of worrying about the difference of perfect squares, I'm going to rewrite that by putting the 2 on the other side, which all I've done is add 2 to both sides, right? So now, if I take the square root of both sides, it just undoes the square on one side, and we're left with plus minus root 2 on the other side. Because don't forget that the square root of any number is a positive version and a negative version. And if we subtract 2 from both sides, we end up with x is equal to minus 2 plus or minus the square root of 2. And of course we get the same answer, which is pretty convenient, otherwise we'd be worried, right? Alright, let's try question B, where we have x squared plus 6x minus 11 equals 0. Now, because b is equal to 6, then b on 2 squared is equal to 6 on 2 squared, which is 9. So when we add and subtract 9, we're not changing anything. And therefore these terms here become x plus 3 squared. And we're left with a minus 9 minus 11, which is obviously minus 20, and that's all equal to 0. So in the first method, we'll rewrite the 20 as the square of the square root of 20. And as a side note that will make our solutions a lot easier, let's remember that the square root of 20 is equal to the square root of 4 times 5, which is the square root of 4 times the square root of 5, which is 2 times the square root of 5. So therefore we can rewrite this equation as x plus 3 all squared minus 2 times the square root of 5 squared. And so now we can factor this as x plus 3 plus 2 times the square root of 5 times x plus 3 minus 2 times the square root of 5, just by using the difference of perfect squares. And therefore by the null factor law, x plus 3 plus 2 times the square root of 5 is equal to 0, or x plus 3 minus 2 times the square root of 5 is equal to 0. So in other words, x is equal to minus 3 minus 2 times the square root of 5, or x is equal to minus 3 plus 2 times the square root of 5. So once again, the alternative method starts here, where we just add 20 to both sides and get x plus 3 squared equals 20. And then when we take the square root of both sides, x plus 3 has to equal plus and minus the square root of 20. Okay, so once again, do not forget we have the minus sign there as well as a positive sign, because a minus times a minus is a positive and a positive times a positive is a positive. Okay, so then we subtract 3 from both sides and we now have x is equal to minus 3 plus or minus the square root of 20. And as we saw before, the square root of 20 is 2 times the square root of 5. And once again, we've got the same answer from both methods. All right, let's move on to part C, where we've got x squared minus 3x plus 1, of course, equal to 0. So because b is equal to minus 3, b on 2 squared is equal to minus 3 on 2 squared, which is equal to 9 on 4. And of course, adding and subtracting 9 on 4 means we don't change the equation at all. And that, of course, ends up being x plus b on 2 all squared, right? Which is x minus 3 on 2 all squared. And minus 9 on 4 plus 1 on 4 is equal to minus 5 on 4. And we're still equal to 0 all up. So when we now set up our 5 on 4 for the difference of perfect squares, we're going to have x minus 3 squared minus the square root of 5 on 2 squared equals 0. And that, of course, is because the square root of 4 is 2. Once again, we're going to now factor that into x minus 3 on 2 plus 5 on 2 multiplied by x minus 3 on 2 minus square root of 5 on 2. And that was just using the difference of perfect squares. So therefore, by the null factor law, x minus 3 on 2 plus the square root of 5 on 2 is equal to 0, or x minus 3 on 2 minus the square root of 5 on 2 is equal to 0. So therefore, x has to be equal to 3 on 2 minus the square root of 5 on 2, or 3 on 2 plus the square root of 5 on 2. And the alternative method again becomes x minus 3 on 2 squared equal to 5 on 4. And we already know what the square root of 5 on 4 is, so when I take the square root of both sides, we get x minus 3 on 2 is equal to plus and minus the square root of 5 on 2. And when we add 3 on 2 to both sides, we end up with x equals to 3 on 2 plus or minus the square root of 5 on 2. And of course, these two answers are the same. So please note that you can write 3 on 2 minus the square root of 5 on 2, or 3 on 2 plus the square root of 5 on 2 as 3 plus or minus the square root of 5 on 2. So of course they mean the same thing, but some people find it neater to have that one fraction like so. And as a pro tip, it's important that you realise even with these complicated answers, we can still check the answer. Okay, so let's do that with A, where we started with x squared plus 4x plus 2 equals 0. And our solutions for that ended up being x was equal to minus 2 minus the square root of 2, or x was equal to minus 2 plus the square root of 2. So if x was equal to minus 2 minus the square root of 2, when we sub that into the equation, we get minus 2 minus the square root of 2 all squared, plus 4 times minus 2 plus the square root of 2 plus 2. And that becomes 4 plus 4 times the square root of 2 plus 2 when we expand the square brackets, and minus 8 minus 4 times the square root of 2 when we multiply through that bracket. And of course, don't forget to add 2. And then I can rewrite that as 4 plus 2 minus 8 plus 2 plus 4 times the square root of 2 minus 4 times the square root of 2, just by collecting like surds. Of course, all the numbers on the left equals 0, and 4 root 2 minus 4 root 2 is also equal to 0, so the whole thing is equal to 0, just as we like. And when x is equal to minus 2 plus the square root of 2, then subbing that into the equation, we get the square of minus 2 plus root 2, plus 4 times minus 2 plus root 2 plus 2. And that's equal to 4 minus 4 times the square root of 2 plus 2 minus 8 plus 4 times the square root of 2 plus 2. With this part representing the square brackets and this part representing the multiplication of the 4 times a bracket. And without going through the next step again, you can see that we've got exactly the same equation as we had at the second step last time, except where the minus the square root and the plus the square root are in different places. So of course that's all equal to 0, which is what we want. So yeah, once again, check the answers if you're not sure. So right now you should pause that video and do questions 2, 3 and 5 in the new book, or questions 4, 5 and 7 in the old book. And then hurry back so we can summarise this lesson. As usual, pre-learning must be done prior to class, but I'm highlighting this fact because in class we must cover 5 and 6 in the new or 6 and 8 in the old. However, it would be great if you could attempt them for pre-learning, because that'll set you up to be able to complete the enrichment section in class, and students who complete the enrichment will find the next lesson very easy. Alright, so for this class, a successful student will understand that completing the square can be used to factor a quadratic equation where integers cannot be found. They'll be able to solve an equation by using the completing the square method to factorise. And finally, recognise a form of quadratic equation that gives no solutions. Alright, so that was a pretty quick lesson, I think. Good luck with all that. Hope you master everything. See you in the next lesson, whether that's in the next video or the next class. Bye.